Alright, ladies and gentlemen, welcome back to another exciting tutorial on geometry. Today we're going to be looking at areas of circles and regular polygons. We're going to be jumping up from the quadrilaterals and triangles that we were doing last time and start looking at some more advanced figures. Circles. You've seen them since first grade. You know what circles are, you know what the radius is, etc. You've seen all these terms before, so I'm going to really quick type R. R always stands for a radius. Similarly, D stands for diameter. You know those terms, you've seen these terms countless times. In this circle, for example, radius, is from the center to the outside of a circle. For example, in this circle, from A to B would be a radius. From A to C and A to D would also be radii, plural of radius. Diameter is the distance all the way across the circle, so from C to D, for example, would be a diameter. I can go and write that down. How do you label a circle? You're going to label a circle just like you do with triangles. You draw a triangle ABC, or a parallelogram, you draw a little parallelogram symbol, and then ABCD. With circles, you're simply going to start with a circle, and you're going to call this circle A. Naming it off the middle. Simple as that. This is circle A. Pi, I imagine you're probably better at me at reciting digits of pi. I only know a few digits, 3.141592. It keeps on going for a while. Pi keeps on going for a while. If you have more digits than me, then good job to you. You're doing great. Formulas. You've probably seen these formulas. You probably saw them in 6th grade and 7th grade, etc. Probably as low as 5th grade. You probably saw some of these formulas. Area of a circle is always pi times radius squared. I'm going to draw out my very best pi. Pi times a radius, not a 3, radius squared. Alright, area is equal to pi r squared, which always brings us to the joke. Well, no, Mr. Reece, pi r round. Nope, actually pi r squared. In our circumference equation, you can write it one of two ways. You can either write it pi times diameter, or since a diameter is really just 2 radii, this diameter is really just 2 radiuses made up of each other. You can also write that as 2 times pi times a radius, or 2 times radius times pi. Both those equations are fine. For example, in this diagram, we have a circle with a diameter of 6. We want to find the area of this circle. Well, if our diameter is 6 currently, what is our radius? You guessed it. We have a radius of 3, half of 6. We could find the area in terms of pi. Notice A equals pi. I'm going to write that as just pi times r squared. We could write this now in terms of pi. That's pi times 3 squared, which is 9. We'd say that the area is really just 9 pi. All right? Area is really just 9 pi. If you want to put that in your calculator, type in 9 times pi, which is 9 times 3.141592, etc. Hit the enter button, and you should get a decimal as well. If you don't write it in terms of pi, that's approximately 28.2743 inches squared. We're still going to use inches squared rather than inches round or something goofy like that, because this is really and actually telling us how many squares that are 1 inch by 1 inch can potentially fit in a circle. Turns out there's a little over 28 1 inch by 1 inch squares that could fit inside the circle. A circle has an area of 20 square inches. What is its circumference? If we want to find that, we first need to find the radius. We're going to do that by typing out our equation. Our area is equal to pi times a radius squared. We know that the area is 20, so we could say 20 equals pi times r squared. If we want to get this radius by itself so that we can actually calculate circumference eventually, I'm going to go and divide both sides by pi. This is going to give us a pretty wonky decimal. Pi's cancel out. This will give us a little bit of a weird decimal. Let's roll with it here, though. 20 divided by pi, I'm plugging that in my calculator right now. That gives me a 6.3662. 6.3662 is equal to r squared. At this point, what do? You guessed it, we go ahead and square root both sides like normal. Square root both sides like normal. Square root of 6.3662 into the calculator is going to give us 2.52-ish, 2.52 roughly. We're going to say our radius is approximately 2.52 All right, we know our radius. We want to know circumference now. We're halfway there. Found our radius already. Circumference is equal to 2 times our radius, 2.52 times pi. If we plug that all into our calculators, 2 multiply by the number that you got, multiply that by pi, should give you about a 15.85. All right. Circumference is a 15.85. Since this is a distance here, 15.85, we're not going to put squared, we're just going to put inches. The distance around the circle that has an area of 20 square inches, the distance around the circle is about 15 inches. This brings us to regular polygons. We've done circles, we've looked at circles. Those are the types of problems that you're going to need to answer over the course of geometry here this year. Let's look at regular polygons. Remember from last semester, regular polygons are polygons that have all equal sides. This side, this side, this side, this side, and this side are all equal to each other. All of their interior angles are as well. The center of this regular polygon, we'd say, is point C. The apothem, which is a fun word to say. Try to say that once, apothem. It sounds like you have a lisp and you're trying to say apothem, except it's apothem, or opossum, except it's apothem. Distance from the center point out to the outside is going to be the apothem, but it's not just any distance. It's the distance, the shortest distance from the center to the outside, like from C to B, would be the apothem of this regular polygon here, CB. Central angle. A central angle is going to be one of these in the inside, one of these 5 angles inside here. Remember from last semester, to find the total, actually let me back up here, these are interior angles, excuse me. With these angles here, we have a circle pretty much. Circles are always 360 degrees. So the central angle measure is going to be 360 divided by 5, because it's being cut into 5 pieces. 360 divided by 5, 360 divided by a 5 is going to give us a 72. That means that our central angle, each of those angles is 72 degrees. Central angle, I could name it anything like GCH, angle GCH would be a central angle. There are 5 central angles. E to C to D would be another example. In regular polygons, we have an equation for solving these things. A always stands for apothem. P is going to stand for perimeter. And then area is always going to be calculated with a pretty simple equation, 1/2 apothem times perimeter. Equation doesn't look too bad. It almost looks like a triangle equation with 1/2 base times height, 1/2 apothem perimeter. Can't be too bad, right? Exactly. It's actually not too bad. In this next equation, or in this next one, we have a heptagon. Remember, that's a 7-sided figure. Start out in this heptagon. If you're drawing along with me, start on this heptagon. Draw a center point. And then connect that center point to each of the outside vertices. We're given a few things here. The area of the regular we want to find the area of the regular polygon. It has side length 2. All right? It has side length 2. In our equation, we need an apothem and we need a perimeter. If we already know that one of our sides is 2 and it's a regular heptagon, that means every single one of these sides is going to be 2. 2, 2, 2, 2, 2, 2, 2. We have 7 of them. Our perimeter is going to be 7 2s, which is a 14 feet. We have a perimeter. Not too bad so far. This next part's going to get a little tricky. We need to bring in some trig here. It's going to get triggy, if you will. Only about 10 people are going to hear that joke. Anywho, we have an apothem, the blue portion here that we want. It's not 2. We'll give you a clue. This base here is being broken up into a couple pieces, 1 and 1. We want to find this top angle. We don't know what it is yet. However, we do know that any of these interior angles are going to be 360, and there are 7 of them, so we do 360 divided by 7. I'm going to type that up here. 360 divided by 7 is going to yield a decimal, 51.43-ish or so, 51.43. If you divide that now, divide that number, 51.43, by 2. Go and do that on your calculators with me. 25.71 or so. 25.71. That means that this angle on the interior here is 25.71. And this is A, the apothem. Lucky for us, it's the apothem. It also happens to stand for the adjacent angle to our side. We already have our opposite. Think back to trig. I know it's been at least, 5 days since you've done trig? Let's go ahead and bust out some trig here. We need an apothem. We need an adjacent. We have an opposite. That's going to be a tan function. We could say that tan of the angle is equal to our opposite, 1, over our adjacent, apothem. We can pull the old switcheroo here. If we divide by 1, 1 times 1 is going to be a 1. We're going to have a tan, 25.71 times an A on the other side. We'll end up dividing both sides by tan, 25.71. What will end up happening here is you're going to have an A on one side, and you're going to have a 1 divided by the tan 25.71 on the other side. If you're having trouble with that, cross-multiplying, reference a few of those trig videos we did earlier. Those will really help you out. On your calculator now, if you do 1 divided by tangent of that 25.71, etc., that's going to give you a 2.07 or so, 2.08. Our apothem is equal to 2.08. I'm going to write that up here as well, 2.08. As a very last step to your equation, we need to find the area of this regular heptagon. I know areas 1/2, so 0.5 times apothem, 2.08, times perimeter, 14. It's not fitting in my box. Oops, oh well. If you go ahead and multiply all those all out, 0.5 multiplied by the apothem, multiply that by the 14. That's going to give you something like 14.54-ish, 14.54. Area is equal to 14.54. Our units here, if the sides were in feet, this would be in feet squared. This is our final answer. 14.54 feet squared is the area of this regular heptagon with side length 2. Remember that number, 14.5, roughly 14.5. I want to show you here that our work verifies in GeoGebra as well. If I pull up GeoGebra here, by the way, GeoGebra is a wonderful tool. If you haven't downloaded it yet, please grab it sometime. It's available on both Mac and PC. I believe they're building some sort of phone application as well. I don't know if they have it out yet. We can go ahead and build a regular polygon. I'm going to build my regular polygon with a side length of 2, so going from 0 to 2. I want it to have 7 sides. There's our heptagon. It has an area of 14.54. GeoGebra did that for us. All the side lengths are 2. Excellent. I like it when math works. For this last example up here, if we are given an apothem this time, remember 2 things we need. We need apothem. We're given it this time. We need perimeter. We're not given perimeter this time. We're going to need to do the exact same thing that we did last time, though. We can go ahead and connect the center to several different places on the outside. We're splitting this triangle up, or this shape up, this circle up right in the middle into 6 different pieces, and then we're splitting it once more in half. So I'm going to do 360 divided by 6 pieces. And then I'm going to divide that by 2. 360 divided by 6 would give us 60, divided by 2 would give us a 30. We know that this angle on the inside here is going to be a 30-degree angle. All right, 30-degree angle. We need to find this distance on the bottom. We don't know it yet. We could find half the distance. Doing some trig, we have the apothem already, which happens to be the adjacent. We need the opposite over here. We don't have it yet. So we could do tangent of 30 is equal to our opposite side that we don't know, divided by our adjacent side, which we do know. It happens to be 14. Cross multiply, I can go ahead and type in a 14 times the tan 30 into a calculator. 14 times tan of 30 in a calculator. That's going to give us an 8.08. All right, 8.08. That doesn't seem right. It is. Trust me. 8.08. All right, fine. 8.08. We have an 8.08 down here. That means that 8.08 times 2, multiply that number by 2 now. You're going to get a 16.16-ish, rounded up 16.17. If you're using a longer number, if you're rounding up a little farther, I'm just going to do 16. 16.16. We know this distance is 16.16. There are 6 sides overall, so I'm going to go and do that number, 16.16. Multiply that by the 6 sides that we have. That's 96.96. 96.96. Switch over to green. 96.96 is our perimeter. For our last step here, we need the area. Area is 0.5 times our apothem, 14 times perimeter, 96.96. And that's going to yield for us, let's see here, 0.5 times the 14, which is 7 times the 96.96. 678.7 or so, 678.7. What units do we have? It looks like we're dealing with inches, so we'd say this is inches squared. Inches squared, not inches round. Take a moment to write that down. All right. Well, that's what I've got for you. Tonight's assignment is also in the book, which can be found on Moodle. If you have any questions, as always, email me, let me know, bring questions to class. Please be memorizing your equations, especially these 2 new equations that we have. On your mastery test next time, you will need to recite these equations off your head. You won't be allowed to use a note card cheat sheet for that. Good luck. Have a wonderful night. Take care.